Welcome back to another YouTube Tuesday. My name is Derek, and today I'm going to be showing you another YouTube channel that you should definitely take a look at. One of the things that I really want to do is be able to have channels that are putting out great content garner more attention. So if you have a channel in mind, leave it in the comments below. That being said, the channel that we're going to look at today is the channel called Go Cell Phone Repair. Let's get into the video. Alright, the channel Go Cell Phone Repair is run by a guy named Mike. He's coming up on 100,000 subscribers. He's posted over 500 videos. So today we're going to take a quick look at one of his more recent videos so that you can get a good idea as to the content that he puts out and why going through some of his content might give you an edge if you're looking to get into some of these repairs. So let's get to it.
Today I'm going to be working with some small components, and to give you an idea of how small they are, I thought I'd do a comparison here. On the left-hand side, we have a grain of brown rice. Right next to it here is a sesame seed. And as we move across here, this little cube you see right over here is a grain of salt. On the right-hand side, we have granulated sugar. And all the way over here, we have a 01005 size component. And that is what we're going to be working with today. Today I have an iPad Pro 11-inch that came in with charging issues after a repair. So let's plug this in and see what kind of charging information we get from our meter here. Because when I plug it in, I can hear the tone. So it is turning on, or it's actually on already. And we are pulling 0.04 amps. See if we can focus on that a little better.
So a lot of the time when I see someone try to replace the battery or work on a device like this, and we have issues where it's not charging, it's as simple as that when they stuck something under the battery connector, they bent the pins. There's a couple smaller pins under the battery connector that if they aren't making contact with the battery, it won't charge properly. It may still turn on because the main positive and negative lines of the battery still make contact, or I see a lot of pry damage. So let's take a look and see which ones he's dealing with here. It's probably one of those two scenarios.
And you'll see right over here, we've actually got what looks like a resistor hanging out next to the battery connector there. And then we've got some pads here that something's been torn off of, obviously. So I think we might have got a little rough, probably prying. I'm not sure how or why you would pry exactly at that spot. It's kind of unusual. But it also makes me wonder if there's anything else funny going on here. You can see the impression from that capacitor there. Hopefully that's nothing unusual, because sometimes the pressure from the sticker will do that. But this is definitely going to be an issue. Let's see. Oh, look at that. So we have a couple components. We have this, whatever that happens to be. All right, so we have something right here. Not sure what that is. And then we've got, like I said, what appears to be a resistor right over here. A couple things missing there. So I am going to go ahead and take the battery screw out, but I want to be very careful because whatever these components are, if we can figure out where they go, we might be able to put them back. And I don't have a donor motherboard for this particular model here. But fortunately, it looks like the schematic has been leaked, so at least we can figure out what we're working with if it comes down to that. Oh, geez, yeah, we've got a mess under here, so looks like pretty much everything got, or was affected, I should say. Okay, there's one more component we can actually save, hopefully.
So it's definitely pry damage in this case. We've got an issue where someone took a pry tool of some sort, either a spudger, their fingernails, some tweezers, something, and knocked off a bunch of small components. Now these components, as you saw him compare them to the rice and the salt and the sugar, like they are super small, and there's not much, it doesn't take much to knock them off. It could be that as well they did some damage to the battery connector, but more than likely it's just knocking these components off.
And so we are missing, wow, we're missing 1, 2, 3, 4, 5, 6, maybe more. Quite a bit of stuff there. I think it's all isolated to this location, but this is all important. The majority of the stuff we need to have. So we're missing 1, 2, 3, 4, 5, 6, maybe 7 components. All right, so let's take a look at what we have missing here. I don't want to go into too much detail on this, but basically your battery has a negative and a positive terminal, but it's also got some lines that are connected to the tablet in order to control how it charges. So it knows when it's low, when it needs to be charged, how much current to allow through, and so forth.
So if you're wondering, this schematic software is ZXW. It's a great schematic software. I really enjoy using it. You could also use JCID or JC Drawing, sorry. And you can also use JC Drawing. They're both good softwares. JC drawing, I tend to like the way that the schematics kind of pair up with the board. That way, if I really need to look at the actual circuit behind just the physical board view, I'm able to kind of read it and understand what's going on.
And that's what this circuit has to do with. These components in this area, they're all related to that circuit. As you can see here, we have something called ppvat_VCC. That is the 4 volts that is going to go to the battery. It's also going to have the battery output to the tablet to power it when it's not charging. So that's pretty much what this is for, and that's what these 3 capacitors here are connected to. So we're going to be replacing all 3 of these because they are there for a reason, obviously. And again,
now, obviously, he was actually able to get the device to turn on. So these capacitors, I would definitely be putting them back if they're missing, but if you really can't source them, there's a good chance that this will actually work without those. You can tend to get away without capacitors unless there's a very few capacitors on that particular circuit. Now, they're obviously there for a reason. They were engineered that way, but capacitors you can kind of get away without putting them back if you're in a pinch. But I would recommend putting them back if you have either a donor board or have access to a schematic to make sure you know which kind of capacitor you are needing to put back and that you put back the right one.
Like I said, I don't want to go into too much detail on this, but the important thing is that these 2 other contacts over here, which I'll show you later on in the video, they serve a purpose as well for the communication between the tablet and the battery. And most of this stuff is going to be connected to those. So like this resistor that we're missing here, this has to do with board temperature. It's called board_temp2_P, and there is a system that prevents the tablet from charging when it's at too high of a temperature. That could be a problem for various reasons. Obviously you don't want your battery getting too hot. So I assume that that's what this has to do with. These 2 resistors, actually all 3 of these resistors that we're missing up here are critical. If we don't have these, we're going to be missing some information that the tablet needs to know how to charge properly. So over here, we have an I2C line, and on the other side, it is connected to PP1V25_S2. So we've got a 1 volt, 1¼ volt line going through here. And then you can see it's connected to this resistor here, which on the opposite side is another I2C circuit. And anytime you have I2C, you're generally transmitting information, and this information is going to be required in order for the battery or the tablet to know what to do with the battery when it's plugged in as far as the charging end of it goes. Over on the other side here, we have gas gauge, and gas gauge is pretty much what it sounds like. It is a name that they've given to this part of the circuitry that monitors the level of the battery. So when you see gas gauge, that's what we're talking about. How much gas is in the tank, how much charge is in the battery, and what does the tablet choose to do with it from there out. So here we've got, again, 1, 2, 3, 4, 5, 6, 7 components that we are going to want to replace in order to get this thing as close to being factory as we possibly can.
What's really nice about having schematics like this is you're actually able to determine what components you need. In fact, if you look where he's hovering over the component, you'll actually see it tells you exactly what it is. It tells you what type of microfarads it is, what percentage of, basically it's composite, the size. You can get all of the data that you need on that particular component when the software like ZXW actually supplies it. It's kind of annoying when you have just the board view without all of this data, because you can kind of only infer or guess, or you have to get a donor board to transplant components because you could potentially be putting the wrong type of component over, as some of them look very similar and are different. Some resistors look like filters, some capacitors look like resistors, it goes back and forth, so you really want to make sure you're putting back the right stuff. But in this case, he has all of the data when he hovers over those components with the mouse. That way he knows exactly what to order or pull from a donor board. It doesn't have to be from this exact location on a donor board. You just need to find the same value and size of component to be able to transfer it.
We are going to want to replace in order to get this thing as close to being factory as we possibly can. And you can see this number 1 pin is connected over here, which goes through U8900, and on the opposite side connects to the gas gauge circuit. And then number 2 over here goes to the number 4, which presumably goes through to, let's see, that's gas gauge 2.5. Most likely is connected from this side to this side. I'd have to look at the schematic to double check. But in any case, you can see all this stuff needs to be present in order for this area to communicate with the tablet. I was able to pull off 3, so yeah, half of them are gone, and we're going to have to figure out where these are. So I will go ahead and isolate the battery, because I want to see if they did any damage to the connector underneath here. And hopefully you can see everything is intact here. What I'm looking for are these 2 very big connectors here, and then a small one to the left of that, which you can see. And then over here, we've got 2 and 2. So 2 of the wide ones and 2 of the narrow ones. So it looks like as far as our battery connector goes, everything is fine. The problem, I believe, is going to be here, because I know we've got some I2C lines that are involved with the charging system. So we need to get at least these resistors restored and hopefully find everything that is missing here. And with any luck, I might be able to do this without pulling the motherboard out. I'm also going to take this sticker off the rest of the way, just to be sure we're not missing a whole bunch of other stuff, which is entirely possible. I guess that's why Apple puts these stickers here, so they'll hold the components when they get torn off the motherboard. All right, yeah, so everything else looks fine. I believe our problem is isolated to this area right here. So this is going to be fun. We'll start by getting some leaded solder on there momentarily. I'm going to see if I can track down the components first of all. Okay, so we're going to do these one at a time. Turns out one of the resistors that we saved is a 10K ohm, and that is going to go right here, this direction. So I'm going to go ahead and put some leaded solder on all these and hopefully make this easier, because I would prefer not to pull the motherboard out of here, if that is an option. We'll find out shortly.
With your multimeter, you can test across the resistor and you can get the value that it is. That way you're putting it back in a place that the schematic tells you to, instead of just guessing, hey, this looks like it might have come off of this particular pad set. And if you're unable to determine what it is for whatever reason, either it's damaged or you don't have a multimeter, you want to go based off of the schematics. I don't see why you wouldn't have a multimeter if you're doing this type of work, but you should be able to get its value with the multimeter and know exactly where to put it back. Now he's adding leaded solder to this, which will allow him to lower the temperature he needs to bring the board up to get things to solder. He still has the board inside the housing, which is totally doable. It's complicated because the amount of planes, and you've got a plastic connector there and the battery. It's a little risky.
And you can probably tell by the way these behaved that we've got some ground over in this area, and that's going to be the tough part to melt. Actually, this is getting sticky already, so I'm going to go ahead and clean up this flux. All right, so we have a resistor right here. Make sure that looks, yeah, it should be fine. I think that will sit without any issues. And we're kind of close to the battery, but I think we'll be okay here heat-wise. I'll get this sticker off before it melts. All right, so that'll work. Like I said, the tricky part's going to be the ground, which we don't have too many of. I think our flux is still good. Let's see if we can chase down a couple more components. I think what I might do is try to hit these first and put the big one on last. So this is going to be a 2.2 over here on the left-hand side. So let's get this one on. Actually, I think we can do a couple at a time here, so we don't have to keep reheating the board. So I'm going to try to track down another one of those. And it turns out getting these components is going to be a process, so I am going to go ahead and attach this one for now, just so we don't lose it. And then I will try to track down either a donor motherboard or order these components from Mouser, who hopefully has everything that we need. We'll find out soon.
So Mouser, DigiKey, even Mobile Centrics will sometimes have these smaller components. You just have to know the values and make sure that you're ordering the correct ones. So, but it's that crucial. You need
soon. All right, my components came in. We are ready to hopefully get this thing working again. And one of the other useful things about flux is keeping things from moving around. So I'm going to warm the board up here just a tiny bit, just enough to melt some flux. And we're going to use that to organize our parts, and hopefully we can get them all on in one shot. That is the idea. I didn't warm it up quite enough there. I want this to flow. There we go. All right, so I'm going to set my components on here. I don't have too much, and we will, I don't know, I might do all of them at once, might do a couple at a time. Let's see what makes sense. You know, I don't want to have to deal with these running together, so I might just do a couple at a time.
If you do a whole lot of components at the same time, sometimes what happens is the surface tension of the actual flux will pull them together and they'll kind of stick next to each other, and it's really hard to separate them because the ends basically solder together. And so it is kind of easier to do it one at a time. Now in this case, it is a little risky, especially if you're not experienced to work in the housing. Now in this case, especially if you don't have experience, it is kind of risky to do it in the housing. The amount of heat you need to provide is substantial. One thing that you could do is you could isolate off by heat shielding the battery connector, the battery. You could do a lot of kind of like, just like in surgery where they isolate the area that they're going to be working and they completely cover everything in cloth. They only isolate the area where they're going to be doing the incision. You can do something similar like that. That way you're not distributing too much heat using your rework station over those components such as the battery or the plastic connectors. So a little bit of prep work might go a long ways in allowing you to put more heat into it instead of extracting the board, which I recommend doing anyway. Take the board out before you work on it when you put heat to it. But sometimes the amount of time it takes to get the board out versus the amount that you're going to be charging, you want to make sure your labor cost is in mind as well, not just, otherwise you may need to, I guess what I'm trying to say is you want to make sure that it makes sense on all ends for the customer and for yourself to do these repairs.
Yeah, we'll just do 2 at a time for now. I don't want to have to do this more than once. And these small ones are tricky because due to their size and being so close together, surface tension can actually work against you. This big one shouldn't be an issue, but let's give it a shot, see what happens here. All right, those 2 should be good. Let's go ahead and get these on for now. Battery temperature seems to be okay. No, don't do that. All right, those should stay long enough. This last one, that one's going to be a pain. All right, I think that is going to work. We'll take some measurements, make sure nothing's shorted. With any luck, this tablet will charge again. Okay, I've got 298 there, so we should be good. And this cap says 595. So yeah, nothing shorted. Let's see what happens. All right, so we've got this thing all put back together. I did actually take out the motherboard to get that stuff cleaned up because I just didn't feel comfortable putting so much heat on there. But let's plug this in and see what we get. All right, we're pulling half an amp, 0.9, 1 amp, 1.8. And I don't know if you heard that, but it actually just powered up. So when we plug it in, we can hear that it is in fact on. I'm going to flip the charger over here, and we've got a good charge in both directions. So that is a success.
All right, so there you go. There's a quick look at Go Cell Phone Repair. Check out his other videos. And if there's a channel that you'd like to see featured in a future video, let me know in the comments below. Even if it's your channel that you want featured. Thanks a ton for watching. We'll see you in the next video.